Start first by looking at one differential equation question that is in this JPJC paper. It is a differential equation, right, that actually reminds me of, hang on. It is a differential equation that actually reminds me of a particular question in the A-level. It is this 2016 A-level paper where they came out with a differential equation question that is like this. Okay, this is the 2016 paper, okay? So the typical differential equation question that we are used to will be either a simple differential. Okay, maybe let me just take a look at the different types of differential equation that we usually will expect appear in our exam. So it will be simple differential. The way to solve it, right, has already been taught to us in our secondary school. So it is just more of like identifying that you are going to be using your secondary school's method, to do simple integration, right, to solve the differential equation. The new one will be the variable separable kind of differential equation, where it is going to be where dy dx can be expressed in terms of a function in f multiplied by a function in terms of a function in terms of x multiplied by a function in terms of y. And it cannot be in any other forms. So if it is a function in terms of x plus a function in terms of y, right, for example, it is not going to work. It's very, very stringent, especially for me, right, who have done a few other differential equations before. We know how difficult it is to solve differential equation, but these are the only two ways that we can solve differential equation, like with knowledge that we have, to solve it independently. Because the other kind of differential equation, first order differential equation, right, will be those that actually comes with an instruction. But of course, most of the instruction will turn out to be almost similar. So we will be using the same kind of substitution process, very, very similar process to try to solve differential equation. But when we were looking at differential equation in the beginning of the year, right, I was telling you it will be actually more versatile for us to try see beyond just the routine substitution, but we see it as an instruction that is going to be given to us to guide us to try to solve the differential equation, either solving it directly or trying to change a differential equation from one that is not variable separable. Now, is it a simple differential? Because we can only solve these two independently without any help. So the aim is to try to change it into one that is either simple differential or variable separable so that we can then continue to solve it. So expecting a help, I think it is actually going to give us more advantage during the exam. So during the year 2016, when this particular question came out, it once again reminds us, right, that the substitution process may not always be appearing in the exam as per what we are familiar with. So what we saw in 2016 was a second order differential equation. And the question actually asks you to sub y is equal to dx dt. Okay, it's actually not difficult, especially if you to look at the solution, right? It is possible to do a bit of exploration and find a way to look at this from the same perspective as well how we have learned it. Okay, but just to get yourself more prepared for the A-level, right? I think our mindset-wise, we must be open to the fact that maybe 10% chance that in the A-level, they may give you an instruction, right, that is totally unfamiliar, and you are just going to react according to that according to the instruction. But the written portion will usually not be very complicated. It just requires you to adapt on the spot. So I see this very, very good JPJC question here, which is also different from the different from the 2016 paper. I think it is inspired by that probably. So I want you to give this a quick try, because I was thinking if I were to be doing this particular question, right, it's never going to be as good as me asking you to try it on the spot. So in paper 2 of this JPJC paper, I want you to try one question for me, okay? It is actually this question number 4, a 6 marks differential equation question. The solution will, again, I want to let you know that if you were to be looking at the solution, you won't find it very difficult. Okay, so most of you should be able to, after pausing and thinking for a while, right, most of you should be able to find a way to solve this, especially when there's a clear instruction of how you should be starting this question. Okay, I'm going to leave you like just a few minutes. Do you think you can try this for me? And just in case any of you, right, has gotten a bit too stuck in this, that means you try already, you think about it already, but you just couldn't continue, please let me know. I want to discuss with you how I think you can do this question. Okay, I just want to show you lah. You know, the aim is to let you try first. Then after that, if needed, I will discuss with you. We will try to do it together. Okay, so just a few minutes. Do you think you can try this? Question number 4 from paper 2. I'm going to start writing down a bit of my solution. So, I mean, if you're able to do, just continue. Okay, just continue and just finish up this question. Okay, again, the aim is for you to imagine seeing such question in the A level and just get yourself mentally prepared, mentally and emotionally prepared to see something that is like this. Okay, I finished this question. Okay, you can again take a look at what I have on the board to just do a bit of verification. I think this kind of question is definitely best experienced through like you doing it. Okay, so you can feel the places where we actually need to do some accommodation to the new instruction that is given to us, because the solution is really not difficult to understand. Anyone else? Any question? Okay, I'm going to move on from this. Anyone? Any problem with this? Okay, I think once in a while, right, if you happen to see questions that are like this, especially when you're doing prelim papers, don't shy away from them, okay? I think it is still good if you are able to spend some time looking at questions that are like this, because we have seen like pretty often, right, where school set some questions, then maybe 5-6 years later, it came out in Cambridge. So, and especially when school set questions that are inspired by Cambridge, okay, it is not going to be something that we're going to see all the time. But if it is a question that is like this, that is inspired by Cambridge, it actually really help us to pick up the essence of the topic. Okay, like what I was saying, to me, I find the essence of this kind of question, right, which we usually see it as substitution, or maybe even subtitled as substitution. It is actually more of like us reacting to an instruction that is not meant to solve the DE directly, but it is an instruction to modify the DE so that it can become solvable within our syllabus. Let me look at another question together with you. Let's go all the way back to paper 1, the first page of paper 1. I feel a bit sad when I was trying out this paper this week, because I find that the first page is actually not that easy. So anyway, can I take a look at this vectors question together with you? I want to try this together with you. Okay, so let's make this a bit more of like a discussion. There are some things inside this vectors question, right, that I think they're actually so useful for us for A level. Especially if we were to be talking about this maybe 2 or 3 months back, or maybe in the first semester, I don't think we will be able to appreciate it. And partly it's also because I think maybe in the first semester, we are never as ambitious as now. We are never as equipped as now. So like in the first semester, when I was telling you, oh, this small little thing, right? Wow, I see it as something that is very important. But first semester, most people will be like, yeah, let me just clear all the big ideas first. So we are going to be seeing some small, seemingly minor thing that is going to be happening in here. But I think you guys will find it very useful. Refer to an origin O. The points A, B, C are given to us as A, B are given to us as A, B. And point C is such that O, A, C, B is going to form a parallelogram. So if I were to be drawing this parallelogram, maybe something that is like this, according to the sign convention in our syllabus since secondary school, when they give us a rectilinear figure OACB like this, we will pick any corner. Let's say this corner. We can pick any corner. Okay, we will pick this corner and we will just go either clockwise or anti-clockwise to name the rectilinear figure. Okay, it is a convention that we should have memorized. So OACB, if I were to go clockwise, it will be OACB, and it doesn't matter, you can also go anti-clockwise or you can start O at any point. The point D is on BC. On BC, maybe point D is here, such that BD is equal to lambda BC. BD is equal to lambda BC, which I was saying I don't find this very easy for me to interpret, so I usually will rewrite it into a ratio format. So BD is to BC is lambda is to 1. BD, if this were to be lambda, BC is 1, which means that the proportion here is 1 minus lambda. And we are also given AE, where E is a point that is on AC. So maybe point E is here, such that AE is mu AC. So AE is equal to mu AC. This tells me that AE over AC is mu over 1. So very similar to this, this will have a proportion of mu. Here we'll have a proportion of 1 minus mu. Okay, and lambda and mu are positive constants. We are told that the area of triangle ODE, this triangle, ODE. Okay, we are told that the area of this triangle is k times the area of OCE. OCE, here to here, diagonal of the parabola, sorry, of the parallelogram, then here. Okay, we are looking at these two triangle where the area of one is k times the area of the other. Part 1. We are going to find the areas of the two triangle, and then we are going to attempt to find k in terms of mu and lambda. Okay, we are going to most likely use cross product to find the area of the two triangle. Let's work on maybe the first triangle ODE. Okay, let's try the triangle ODE first. So I will be going for a half times of modulus of OD cross OE. Okay, in order for me to find the area of this triangle. And to do this, I need the position vector OD, I need the position vector OE. For OD, I'm going to use ratio theorem. And to apply ratio theorem, I know that this here is B. What I'm lacking is this vector, OC. And OC is the diagonal of the parallelogram. So by parallelogram law, this is going to be equal to A plus B, right? Okay, A is here, vector A plus vector B is going to give me OC. Or I can also see using triangle law, A plus B is going to give me OC. So with this, we can find OD. OD is going to be equal to lambda of OC. OC is going to be A plus B, then plus 1 minus lambda of B divided by lambda plus 1 minus lambda, which will be giving us lambda A, lambda B plus B minus lambda B. So lambda B minus lambda B, it will disappear. OD is going to be this. And we will also try find OE. Using the same ratio theorem strategy, we will be expecting the vector to look almost similar to this. Let's see. So it is going to be mu times of OC. OC is going to be again A plus B, then plus 1 minus mu of this, which is going to be vector A, divided by again 1 in the denominator. So we have a mu A minus mu A will disappear, and this times this is going to be A. So we have a then after that we will have a mu B. Okay, and as expected, they're almost the same. So with this, we can, I guess, then find the area of the two triangle, of the first triangle, the area of triangle ODE. So this, according to our plan, is going to be half times of OD cross OE. So it's going to be half of modulus of OD. OD is lambda A plus B cross OE. OE is A plus mu B. This is going to be A cross A. A cross A is going to be a 0 vector. Then A cross B, we will have a plus lambda mu A cross B. This cross this plus B cross A. B cross B, this is going to be a 0 vector. And in order for me to merge these together, I am going to rewrite this as half. Then here will be this A cross B. B cross A is the same as minus A cross B. So we will have this, which is going to be equal to a half. It will be equal to a half modulus of lambda mu minus 1 of A cross B. Okay, so this will be the area of triangle ODE. I'm going to do likewise for the other triangle. The other triangle is triangle OCE. Okay, so for this other triangle, it is going to be half of OCE, half of OC cross OE. Yep, OCE. So this is going to be half of OC. OC is A plus B cross OE. OE is this. So it's going to be A plus mu B. And this will be A cross A is going to be 0. This cross this will be mu A cross B. This cross this is going to be B cross A. B cross A, I might as well just directly write it as minus A cross B. Then B cross B is going to be equal to 0. We are going to stop here, which will be giving us half of mu minus 1 of A cross B. Okay, so we have this. And this is when we are going to be matching the area of this to be equal to K times the area of this, right? That's what the question say. The area of this triangle. So we have a half modulus of lambda mu minus 1 A cross B is going to be equal to half of mu minus 1 then A cross B. Okay, I need to plan this with you a bit first before I know what we are going to be writing. So in the next few steps, we are going to be equating this to, it's going to be K times of this. Okay, in the next few steps, right, this will start to, it will probably end up with something that is like this. Okay, the area of this triangle is K times the area of this. And in order for me to find K in terms of lambda and mu, we will need to remove this A cross B, which means this which are scalar numbers, I will probably want to consolidate them and break it apart from the A cross B. Okay, right? I'm going to retain this, but I want the A cross B to be by itself so that I can cancel away on both the left and right hand side. I cannot cancel away vectors. I can cancel away scalar. So what I think I'm going to do is I'm going to write it as this. You don't write first because this is going to be incorrect. Okay, and I just want you to point out to me how I can correct this mistake. So if I were to be doing this, right, I can potentially write something that is like this. Okay, this is wrong. Okay, this is wrong. Then this is going to be half, then mu minus 1 modulus of A cross B. Because if I can do something that is like this here, then this and this modulus of A cross B can be cancelled. Okay, and we know that when we equate this to this, modulus of A cross B can be cancelled again is because it is a scalar quantity. Okay, A cross B is vector, but modulus of A cross B is scalar. So can you tell me what is wrong with what I've written down both here? That means from here to here, I've already made a mistake. Here to here, here to here. This is the kind of mistake that you really don't want to make during the A level. You know all the concepts, you know all the theories, you have been practicing your vectors, but small little minor mistake that is like this is still going to get you 1 to 2 marks minus off. Right? If they were to see this as the same mistake, then maybe they will minus 1 mark. But if they will see this as two different mistakes, then you're going to get 2 marks minus off. Anyone can point out to me what is wrong, for example this, what is wrong with me going from here to here? Anyone can point out to me? What is wrong when I go from here to here this way? Because if you were to see the JJC paper, right, they point out exactly the same thing. Okay, they have a little speech bubble or little box, right? They actually point out the fact that students tend to do something that is like this. Being able to watch out for this can actually be a big advantage to us if something similar to this happened to us in the A-level. Anyone can point out to me what is the mistake when I go from here to here, here to here? Okay, assuming that none of you are able to point out to me this, right? We know if we can just study and make sure that we know this, it is already going to be our advantage. Okay, so listen to this carefully, okay? I mean, now it is just 3 weeks before the A-level, and if you guys cannot tell, most likely there are a lot of people in Singapore who also cannot. So if you can, from this point onwards, a lot of advantage, which is to work on this modulus function thing. Okay, when I work on modulus function in the exam, okay, when I work on modulus function in the exam, the most casual way that we will work on the modulus function is, of course, when we see modulus of x, we just write it as plus or minus x. Okay, this is the most casual way of dealing with the modulus function. This is actually not very sound. Okay, but you must pronounce this as plus or minus x. Okay, if you have to pronounce this as plus and minus, sorry, I can't even say it. If you pronounce this as plus and minus x, right, it's just weird. Okay, so you must pronounce this as plus or minus x. So the first way that I'll react to a modulus function is to do this, very casual. But if I were to want to verify some things that I'm going to try do for modulus function, for example, taking out a constant out of the modulus function, right, I will usually use the numbers to verify. I find it very quick for myself. So for example, if it is modulus of this, okay, I will see this as 3 modulus of x. Or if I were to see this as 3 times 4, I'll just ask myself, is this the same as 3 times modulus of 4? You know, if it is the same, then most likely it is correct. Then if it is minus 3x, is this the same as 3 modulus of x? Or minus 3 times 4, is this the same as 3 times modulus of 4? Okay, it is still the same. Yep, I think this is okay. Okay, that means when this become like that, I mean when I move a negative out of the modulus, it will just become positive. Okay, and if so my first one is this, the second one is to use number to just do quick verification. Or if these two numbers still fail, right, I will just do one last verification. This last one is actually the most powerful. Okay, it will cause you to pause and think the longest, but it is really the most powerful. There are some people who misunderstand the modulus function, thinking that, hey, it is plus or minus x. Then isn't it failing the vertical line test? It is not. Modulus function is a piecewise function. Let me show you the modulus function again. So if you were to look at what we wrote down in our revision, or you can just go into the internet, search on Wikipedia or whatever. If you were to see a modulus function, modulus of x is defined as a piecewise function. It's a two-piece function, where if the domain is going to be bigger or equal to 0, then the output of this will just be x, no change. But if the domain is less than 0, strictly less than 0, then the output will be negative of x to make it into a positive number. Modulus function is like this. That is why if you have a negative 3 belongs to here, so it will be output as negative of negative 3, so you become positive 3. Okay, in our Singapore version, we go for bigger or equal to 0, strictly less than 0. In some other countries, they go for strictly bigger than 0, less than or equal to 0. I assume, okay, that's what I read from Wikipedia. But anyway, coming back to here, right, you cannot be very casual about modulus function in this semester. In the previous one, yes, you just anyhow write, okay, fine for you lah. But here, right, if I want to shift this out of the modulus function, if I'm unsure whether lambda mu minus 1 is plus or minus, if I'm unsure, when I shift it out, right, then this has to be a 2/2 modulus of lambda mu minus 1, then modulus of A cross B. Okay, I need to retain this modulus to impose a restriction on the output of this. so that the output of this is always positive, because I am unsure. I cannot decide at this point. I'm going to use a notation to tell people that this is supposed to be the output, but I can't do anything about it yet because I don't know what is the domain. That is how you're going to manage this modulus function. But the thing is, if you know what is the domain, if you know what is going into the modulus function, let's analyze. What is lambda? What is mu? The question says that lambda and mu are positive constants. And if D were to be a point that is lying on BC, that's what the question says. That means this lambda, this mu, right? They must be numbers that are between 0 and 1, right? It must be less than 1, which also implies that lambda times mu must be a number that is less than 1, which means that lambda times mu minus 1 is a negative number. You get what I'm trying to say? So from my analysis, right, I cannot just simply remove the modulus. Okay, I will either not remove the modulus and leave it as just like this, or what I'll do is I will say something that is like this. Since lambda is between 0 and 1 and mu is also between 0 and 1, this tells me that lambda mu must be less than 1, which also tells me that lambda mu minus 1 must be less than 0. So we verify that it is a negative number. So this is going to be equal to half of minus lambda mu minus 1, then modulus of A cross B. Okay, because it is a negative number. You get what I'm trying to say? Okay, this kind of detail, you must make sure that you find them very, very useful, okay? It's like they are useful. It's just that if our mentality is such that we don't care about such details, we are still continuing to look at the big ideas, which most of you are already very okay with them, you actually miss out your A or B during the A level because of all these small little details. So this is supposed to be half of 1 minus lambda mu modulus of A cross B. Okay, the same goes for this. I cannot just simply remove the modulus. The modulus must remain if I cannot tell what is the input into the modulus function. Okay, so it will stick there. But if I can tell, then I can go through this piecewise function. In this case, can we tell? Yeah, we can tell. Because mu is going to be less than 1, so mu minus 1 is going to be negative. That is why from here, it is going to be half of negative of this, which is going to be 1 minus mu, then modulus of A cross B. To me, I find that this is very, very useful for us to try to capture before the A level. Very, very useful. Okay, and we can see it. Yesterday when I tried, it was the same. No one actually saw it. Or maybe people see, they don't dare to say yet lah, okay? Because they are still doubtful, which means that this kind, very fundamental things which can happen a lot of times here and there can be our very, very big advantage. Okay, so we have this, and now we know that the area of this is k times of this, so therefore we know that half of 1 minus lambda mu modulus of A cross B is going to be half of 1 minus mu modulus of A cross B, and this time with this as the scalar quantity, we can cancel them out. Sorry, k times of this. It will be k times of this. Okay, which means that k is going to be equal to 1 minus lambda mu divided by 1 minus mu. Okay? So this is the number that we have for, this is the representation that we have for k. Let me write it down here. So we found that k is 1 minus lambda mu over 1 minus mu. Okay, we are going to make use of this to try to do part 2 of this question, where we are going to try find k. And from part 1, the information that we will probably still make use of from part 1 to do this will be the position vector of C, D, and E. Let me write them down here also. So just now we have OC to be equal to A plus B. Then we have OD. OD is equal to, let me write it out. OD is equal to lambda A plus B, and OE is equal to A plus mu B. Okay, so this was what we have gotten from the first part. Let's look at the second part. The second part, F is a point that is on OC and ED. F is a point that is on OC and ED, informs me that F must be the point of intersection between the two lines. And it is also given to me that OF is to FC is 6:1. So OF is to FC is 6:1, and DF FE is 3:4. So here is 3:4. Okay, we have this. And we want to make use of this to try to find the values of lambda and mu, and we want to calculate the value of k. Okay, can I just be totally transparent to you about how I did this question, because I did it in a very robotic way, okay, which I didn't like. Okay, but I really did it this way this week when I'm trying out this paper. You know, I told you before, right? For a question that is like this, you should try to avoid using ratio theorem, right? I mean, we have done a few times of those questions. So I was telling you, the best way, right, to find this is to work on coming up with the equation of two lines, then try to let the equation of two lines be the same to find the intersection between the two lines. And then after that, most likely, if you can think about their three conditions, A and B are non-zero, A and B are non-parallel, then if these two is not existing, then you can match the coefficient to coefficient. Remember that question? So I was telling you default, okay, default must be just whack that. Don't go and try ratio theorem. Okay, just so I did that. Okay, and I'm sad to tell you, right, that I did that and it became so ridiculously messy. Let me show you what I did. So first I tried to form the equation of OC. OC is R is equal to the position vector of a point. I can pick the origin, the easiest possible point. So origin plus lambda and mu are already used, so I'm using alpha. Alpha of OC, the direction that is parallel to the line. So OC is this, so A plus B. Or I can just simply write this as alpha of A plus B. Okay, my attempt was to solve this as a pair of simultaneous equations, okay, to find the intersection between the two lines. The other one is going to be the line that passes through DE. Okay, so this is R is equal to, if I were to use the position vector of D, it is going to be lambda A plus B. Okay, this is OD. Then plus, I'm using alpha here, so beta. Beta of here it must be DE. Okay, the direction. So for DE, it is going to be OE minus away OD. So it will be this minus this. We will have 1 minus lambda of A plus mu minus 1 of B. Okay, so here I'm going to write it 1 minus lambda of A plus mu minus 1 of B. Can you see the disaster that is boiling already? It's so bad, you know, because when I try to match coefficient to coefficient, I mean, first of all, of course, I try to see, okay, are A equal to 0 and B equal to 0? Are they zero vectors? They are not. Okay, they are not zero vectors. So because, I mean, if there are zero vectors, we don't even need to talk about the area. You know, the whole thing is just not there. Okay, so this is not working. And is A parallel to B? A is definitely not parallel to B. The question says that OACB forms a parallelogram. So this also cannot happen. So this justify for me to match the coefficient. The coefficient on the left hand side, the coefficient of A is alpha. On the right hand side, the coefficient of A is lambda, then plus beta of 1 minus lambda. I see this, I know it gone already. Okay, very much gone. If I were to look at the coefficient of B for B on the left hand side is alpha. On the right hand side, the coefficient of B is going to be 1. Then after that, plus beta mu minus 1. Okay, if you are still very, very focused, right, you may still be able to solve it, because our objective is to try to find the values of alpha and beta. Okay, so if my objective is to find the value of alpha and beta, we do have a pair of simultaneous equations in terms of this. And hopefully by matching this to this, I can find the value of beta. With the value of beta, I maybe substitute back into here to try to find the position vector of f. Goodness, it's just very bad. I mean, the question just gave how many marks? The question just gave us 3 marks. Okay, it's not worth it. So, I mean, in the end, I came up with, I changed my strategy and I came up with the answer, but it makes me think, how can I do this question better? I don't want to see this particular one as a one-off question because no matter what, it actually makes use of a process that is familiar to us. So I was just staring at this question, okay, just asking myself, can I get myself a bit more prepared just in case something that is like this come out in the A level? I mean, if I cannot think of one that is satisfactory, I'll move on now. Okay, it's not like I'm going to generalize every single problem that I face in exam so that I can come up with a formula to react to them. Okay, but when I look at this, I do have a generalized way of looking at this. This is actually different from all the past few questions that we did when we tried to find the intersection between the two lines. It worked for them, but the reason why it didn't work for this, right, is because if you were to look carefully at how this question is being phrased, they're asking you to do the reverse of that process. They're not asking you to find OF. They already gave you OF. That's the difference. They gave you OF and require you to reverse the process to find unknowns that is in the process. Okay, it is a reverse thing, critical thinking. We have talked about it. Okay, sometimes they ask you to do this, and in the exam, they may ask you to do in the reverse manner. Why are they asking you to do a reverse? Let me show you what I mean, okay? Because there is still information that we have not used, definitely, which is all these ratios that are given. But these ratios that are given, right, for example, 6 and 1. Can you see? If it is 6 and 1, we already can tell that OF is equal to, if OC is this, then OF is equal to 6 over 7 of A plus B, correct? OF is already this. In fact, it is already helping me to solve for this. Alpha is 6 over 7. Solve. I don't even need to find it. I was trying so hard to find, and I realized that, hey, because they are doing a reverse, we don't need to find this alpha, we don't need to find this beta. They are trying to give it to you. For example, another way for me to look at OF, right, can be making use of this 3 and 4 ratio. For example, if I were to use this 3, then I'll go for OD, then plus 3 over 7 of DE, right? OD plus 3 over 7 of DE. It actually again tells me that beta is already 3 over 7. They have already given me this information. Okay, so this is going to be equal to OD is going to be lambda A plus B plus 3 over 7 of OD is equal to this. This I can't avoid. It is going to be 1 minus lambda of A plus mu minus 1 of B. Then I match the coefficient. Matching the coefficient of the left to the right hand side because these two are the same. Okay, they are both OF. So this is going to be 6 over 7 is equal to the coefficient of A on the right hand side is going to be lambda. Then here is plus 3 over 7, 1 minus lambda. From here, you can really solve for the value of lambda. Lambda is going to be equal to 3 over 4. And if you were to look at the coefficient of B, we have a 6 over 7 on this side. And on the other side, the coefficient of B is going to be 1. And then plus 3 over 7 of mu minus 1. This will help you to solve for mu. Mu is going to be equal to 2 over 3. And therefore, K is going to be equal to 1 minus lambda mu 2 over 3 divided by 1 minus mu 2 over 3. K here is going to be equal to 3 over 2. Okay, I learned quite a bit of things from just this one question alone because I mean, I'm okay with the modulus notation because whenever I see modulus and I want to bring something out, I've already trained myself to pause and think. Okay, and because I train myself to pause and think, right, it doesn't actually take very long. Okay, the pausing becomes shorter and shorter and shorter because I just keep training myself to think from different perspectives. So that I've already been okay. I'm okay for part 1. Okay, it's just that I discovered this week that a lot of students are not okay with doing that manipulation in part 1. Okay, which is a good discovery because we are able to spot this before the A level. Let's make that our advantage. The second one is something that I learned myself, which is question that is like this do exist. Okay, a reversal of a common process that we have. In exam, if I were to do it in the usual way, because I didn't spot that it is a reversal. Okay, but as long as I am assured that this is the way to do for a question that is like this, then it is totally okay that I just find a way to U-turn during the exam, like what I did, right? We can't tell every single thing during the exam, like now. Okay, so flaws, problem that is like this can occur during the exam. But our strategy is, if it really happens, we just process the information again, and we just do some tweak during the exam. And an A caliber student is not one that won't make any mistake throughout the entire paper. Okay, an A caliber student, right, is someone who, even when you make a mistake during the exam, you can find a way to rectify it. I never knew that all along when I was in A level, right? I always think like the student who get A, they always know everything that they want to do. Or to top in the school, they always know what they are going to do, what they are doing in the full paper. Then until when I go to the university, then I realized the top student actually make a lot of mistakes during the paper because I was the top student. so I make a lot of mistakes. I realized, wow, goodness, I don't even know that I can get such high marks, right? But I keep rectifying. Maybe some other top students, they don't need to rectify so much. Okay, but I actually make a lot of mistakes in my exam, but I managed to correct. But anyway, let's continue. Let's take a look at another question. I think this is also a good question for us to review some processes that we have been discussing, but not as much in the last few weeks. We have a curve C. A curve C is y is equal to x squared plus 5 over x minus 2. Prove using an algebraic method that C cannot lie between two values to be determined. Okay, we have talked about this a lot. And there are a lot of students who also, no matter how many times you tell them about it, right, they just either cannot do this question or they are just doing it wrongly. Okay, and I personally believe, I don't think you guys are like that already, but I personally believe that it is because to do this question well, you need to just understand a lot of things that is happening in the background and then plan your way so that the thinking process is thorough enough so that you don't need to spend time doing that during the exam. The first thing is to understand what exactly this question is talking about, because the last 3 or 4 times when A-level set this question, it is definitely inspired by A-level. It's common A-level TYS question. Because some even went beyond your tenure, your TYS, your current TYS. So throughout the entire history of H2 Math, they keep setting this. So when they say C cannot lie between two values, we can understand that better if I were to just have a glimpse of how this graph is going to be like. If I were to be doing a long division to this, we will get an oblique asymptote. And looking at the format of this, we will have a vertical asymptote. The vertical asymptote is x is equal to 2. Oblique asymptote, we will have to do a long division. But if I were to press this to my calculator, we will be getting a graph that is like this, here and here. Okay, if I were to press into the calculator. So what the question is saying that curve C cannot lie between two values. They are trying to talk about these two values. Okay, curve C cannot lie between two y values. So our objective is to find the y values of these two positions. Okay, that is the aim of this question. So in order for me to find these two y values, right, in general, there are actually 3 possible, okay, in general, there are actually 2 possible ways, but the way that this question make it, right, there will be 3. The third one is probably the least popular. The first way to find this is definitely by drawing the graph directly onto the GC. Okay, from the GC, we can find minimum point, we can find maximum point, then the y coordinates will be the points. Can this come out in exam? Yes, I've seen it coming out. And then when it came out in exam as a 1-mark question, I see students doing long processes because they memorize some stuff. Okay, so we can expect ourselves to be using a GC if they didn't mention words like using an algebraic method. Another way that we can try to do this particular question, right, is we find dy dx and let dy dx be equal to 0. by letting dy dx be equal to 0, most likely we will find the x coordinates of the 2 points here, maximum and minimum point. Then with the x coordinates, substituting them back into here, we should be able to get the corresponding y coordinate. Just in case the question wants the exact form, then this can be an alternative. But then the thing is, if the question says use an algebraic method, prove that C cannot lie between the two values, it is very vague. Okay, I don't think this question is phrased well, but the intention is very, very good. Okay, so we need to understand the intention of this question, okay? Because for those who didn't understand the intention, they will start to argue that because these two are not the acceptable method. Okay, we have method number 3. So some students will start to argue that algebraic method implies that you cannot go for calculus, you cannot go for dy dx. Some students argue that, which I can understand again, it is because the question is indeed pretty vague, but that is not the intention. Okay, algebraic method, to me, I cannot really define it to be one that is strictly no differentiation, because I've seen question that can only be done as differentiation as a A-level question, but the question also say use an algebraic method, find stationary point, something that is like this. Okay, so for the third method, right, I think I told you guys this before. Let me just talk about the experience that I had with one student, right? It was this student from APGP after the prelim, and I think it was in the year 2018. After prelim and after he have gotten back his result, right, he asked me this question. He said that he was marked wrong when he let dy dx be equal to 0, and he knows that his answer is incomplete. Okay, so it's not entirely wrong, but it is incomplete. And he also understands that he shouldn't be using dy dx from the beginning anyway, because some teachers, they won't even give marks if you have to use dy dx is equal to 0. So he asked me, why? Why is it that when he let dy dx be equal to 0, I mean, he knows that it cannot be used. Okay, he should be using the third method, which we're going to try to discuss. But he was asking me, why is it that when he let dy dx be equal to 0, he couldn't find a complete answer? Because he always managed to find it when he's doing his revision. And I think for that paper, APGC paper was tough last time. So, I mean, this year is also pretty tough. Then I think he got 60 plus, so he's actually quite strong in his math. So when he asked me, right, I gave him my most honest answer, okay? I told him, I don't know. I don't know because no one is supposed to know. No one is supposed to know because in order for you to let dy dx be equal to 0, right, you must have one criteria, which he didn't meet. I also didn't meet. That's why I have to say I don't know. That's why he didn't complete the thing. When you let dy dx be equal to 0, it's not like you trying to find stationary point or whatever, you know. Sorry, when you let dy dx is equal to 0, it's because you saw the stationary point. You saw the graph. The graph is the one that trigger you to apply dy dx is equal to 0. So when he asked me, right, I said I don't know because I've never seen the equation before. It's not even like this. It's more complicated than this. So I told him, why not? Let's try to draw the graph first before we try to discuss why dy dx is equal to 0. Didn't manage to get him the answer. So when we tried to draw the graph, I think it was a graph that was something like this, okay? So there was a minimum point here. Okay, and when he let dy dx be equal to 0, he found the value of x that is for this minimum point. But for the rest of the parts of the graph, right, it was something that was something that was like this, I think, like this. So what is the set of values that the curve C cannot lie between? It is actually this set of value. One is from here, the other one is the horizontal asymptote. And you don't find horizontal asymptote by letting dy dx be equal to 0. Like it is, yeah, it is just not, right? So when I drew this graph for him, I mean, we drew it out together. So the moment when he saw the graph, right, he actually had his answer. I didn't even need to tell him. He said, oh, I understand why already. Because I didn't manage to find these two. Because they are not triggered by dy dx is equal to 0. Horizontal, vertical asymptotes, like what we have mentioned, they are supposed to be done in exam, right, by first having an idea, then you curate the algebra yourself on the spot based on the situation. It's very different from stationary points where you know dy dx must be equal to 0. And because he didn't see the graph, he assumed that every time it happens, right, it happens at stationary point. That was his failure. Okay? So the idea of this question, if I can rephrase this, right, it is to prove using a non-graphical method. That is what this question is about. To prove using a non-graphical method. The set of values, the C cannot lie between two values. So in order for us to do this, we need a process that you don't need to reinvent, a process that you have to draw inspiration from your secondary school. So what I suggest that you do, right, is to name this as equation number 1, and you kick off a process that is from discriminant in your secondary school. Create a scenario where you have a curve cutting a horizontal line, secondary school. Then you discuss about whether this curve and the horizontal line are going to meet, are going to intersect, are not going to be intersecting at all, are going to be in tangent. Most likely you're going to be ending up with a quadratic equation, and based on the quadratic equation, you bring forth discriminant. Okay, that is how you should be doing a question that is like this. So for example, if I were to let this be equation 1, this I introduce it as my equation number 2, which means that I will be looking at a horizontal line, y is equal to k, to be interacting with this curve. And to look at their interaction, I'm going to let equation number 1 be equal to equation number 2. So x squared plus 5 over x minus 2 is equal to k. This will be this minus kx plus 5 plus 2k. This is equal to 0. Our attempt is to try to solve for the intersection between the horizontal line and the original curve. But then the thing is, I actually don't want this horizontal line to be cutting the curve, because I do want it to be hovering at the region that the curve C cannot lie between. So in order for this horizontal line to be hovering at the region where the curve C cannot lie between, then I'm going to let the discriminant be strictly less than 0. Letting the discriminant be strictly less than 0, we have a b squared minus 4ac, which is going to be less than 0. Solving for this, you are going to be getting k to be between minus 2 and 10. And what is k? K is y. Okay, because we are working on the horizontal line. That's why we chose that geometry, horizontal line, never oblique horizontal. That is why when y is between minus 2 to 10, this is going to be the region that the curve C cannot lie between. You get the idea, right? Okay, it is a very meaningful question, and you're supposed to explore this meaning before the exam. And that is why for those students who start trying out this kind of thing during the exam, right, it's very hard to get it to work. It's not even difficult to understand. It's just too much thinking that is involved. So you should transfer this to be before the exam. Okay, and I do know that there are some students who don't do this, don't visualize all these things at all. They will just simply take this, cross multiply, get an equation in terms of x squared and y as the coefficient. Then you do something that is like this. I mean, if that is really okay for you, right, you can just continue with that. Okay, but I do want you to know that the flaw of going for that strategy, right, is you are doing it basically just as an algebraic obligation. If the question were to twist a little bit too much, right, which we cannot imagine how it can be done now until maybe somebody did it or A-level did it, I find it a bit weaker as compared to this, because this is anchored on a meaning. Meaning, the meaning by itself, if it is tested, it won't change. It is always the writing part that is going to change. So if you are doing just simply the writing without a proper anchor on the meaning, right, just be aware, okay, it can be a little bit potentially tricky. Okay. The last time when A-level said this, it was, I think, in the year 2017. Yeah, I think it was the year 2017, where they, 16 or 17, where they changed the question a bit. They changed this to a function question. They say that this is equal to, that question says gx. They say this is gx, and they want you to find the range of the function. Okay, this is gx. Using an algebraic method, find the range of the function. So to find the range of the function, using an algebraic method, again, we are not going to use this, we are not going to use this. We are going to see the algebraic method as a non-graphical method to find the range. So what we will do is, we will try to find this y value, and anything that is above this y value is going to be the range. We are going to try to find this y value. Anything that is here is going to be the range. So if I were to just customize this for this question, right, what I'll do is, I will want the horizontal line to be cutting the graph. I'll want the horizontal line to be cutting the graph instead. Okay, I want to find the region that the curve C can lie, because that will be the range of the function g. You get what I'm trying to say, right? Which means that instead of doing this, from here, we are going to let the discriminant be bigger or equal to 0. Okay, we're going to let the discriminant be bigger or equal to 0. Some people question, why can't I let the discriminant be equal to 0? You know, if it were to be this case, right, I should just let it be equal to 0. Should I let it be strictly bigger than 0? We must again question ourselves. What is this number 3? Number 3 is a non-graphical method. ask yourself, why did you say that you want to let it be equal to 0? It's because you saw the graph. You saw that it is touching the graph at one point. That is why you say let the discriminant be equal to 0. But what if it is that horizontal asymptote thing again? Okay, and because you are uncertain, that is why in your solution, right, you should choose it to be bigger or equal to 0. You get what I'm trying to say? Okay, because you are not supposed to refer to the graph to make this decision. You're supposed to make this decision algebraically. Okay? Then part 2, we are going to try to sketch the curve C, and it is already almost sketched here, okay? But we will need this curve for the second part. So let me just do a quick sketch of this curve. So y-axis, x-axis, if you're to do a long division, you are going to be getting an oblique asymptote. The oblique asymptote is y is equal to x plus 2. We will have a vertical asymptote. The vertical asymptote is x is equal to 2. The graph is going to be something that is like this. And for this portion here, it is going to be like this, tending towards the vertical asymptote. We should be indicating all the maximum point, minimum point, and points where the curve cuts the axis. Okay, but I'm going to skip that for now. So that I will not complicate this, because I want to focus on part 3, which I'm going to introduce another graph into here. I just don't want to make it too messy first. So for part 3, by adding a suitable graph onto this sketch, we want to deduce the range of values of h, for which this equation here, x squared plus 5 squared, then x plus 1 squared, x minus 2 squared is h squared x minus 2 squared, for which this equation here has at least one positive real root. Okay, the criteria is for this to have at least one positive real root. Okay, so this is the criteria. We want to sketch another graph on this such that this equation has at least one positive real root. We had a strategy. Okay, we had a thinking process. The thinking process is, if you were to look at this and you know immediately what is the answer, just go ahead and go and write down the answer. Okay, if you are confident enough, just go ahead. But if you are not confident enough, then we may have to think a bit more during the exam. And the thinking a bit more, let's try to revise that again. So according to what we have discussed during our revision, right, the thinking will usually involve these 3 steps. Okay, and I do suggest that you do it systematically so that it will increase the chances of you getting this correct during the exam. And I don't want you to just apply this during the exam. I need you to apply it like immediately. Okay, in case some of you have not tried this before, right, just try it first. Maybe it is not your kind of vibe. You may not even want to do this during the exam. Okay, but for those of you who had already been doing this, right, since we have discussed this since last year with some of you, please continue to use this if you are stuck. Okay, so let's just do a quick recap on this. This is trying to create for ourselves a framework of something that we are actually very familiar with. And that is actually the intention of this question also. It is a test on simultaneous equation, but it is a very, very full test. A very complete test of simultaneous equation. It will involve us trying to analyze simultaneous equation algebraically all the way until when we try to analyze simultaneous equation graphically. That was what we learned about simultaneous equation in our secondary school. So the very first thing that I want you to do is to analyze this entire scenario as a simultaneous equation question algebraically. The first thinking. Okay, analyze this as a simultaneous equation algebraically. We know that this is going to be the result of a pair of simultaneous equations. One is definitely going to be the hint that is given to us by the question, which is y is equal to x squared plus 5 over x minus 2, which is this curve. Okay, this is y is equal to x squared plus 5, x minus 2. So this is supposed to be equation number 1. Equation number 2, right, is yet to be found. And my first objective is to find equation number 2. How to find it? Just like how I've talked to you guys about horizontal and vertical asymptote, what is that difference? The difference is they give you an idea and you work out the algebra. Secondary school, they give you the idea, they tell you the first algebra, you continue from the first algebra. It is already pre-briefed. Over here, you have the idea of trying to reverse a simultaneous equation, you work out the algebra yourself. So from your observation, or rather from my observation, I see x squared plus 5 here, I see x minus 2 here. I'm going to divide this entire thing throughout by x minus 2 squared, giving me x squared plus 5 over x minus 2 squared plus x plus 1 squared is equal to h squared. This immediately gives me a hint for what it is here, because what that is here is going to be y squared plus x plus 1 square is equal to h squared. Because if I were to substitute equation number 1 into equation number 2, I'm going to be getting this. Okay, we are still trying to solve simultaneous equation, but we are trying to reverse it. Okay, we are trying to take it apart. And the thing is, once you have gotten this, my suggestion is to present this statement. Okay, those of you who had went through this with me, right, I was telling you very clearly, please write down this step, okay? Because some students, they saw this, but they left this in their thoughts. They never give the examiner a chance to mark your paper. Our marks comes from what we write, not what we think, sadly. So we must give the examiner the opportunity, okay? So I'm going to make sure that I write down the equation of the second graph as, for example, in this case, right, I'm going to write it down as this plus y squared is equal to h squared, okay? I'm rewriting this because I know this is a standard graph. Reacting to a graph in a standard manner is always going to be our advantage. It is a circle. And the reason why we were saying that we should write down this line is because sometimes for the second graph, it's hard to draw. Okay, even if it is a straight line, right, we have seen it before, it may be hard to draw. And when it is hard to draw and you don't draw it or you couldn't draw it, then this is where you create an opportunity for the examiner to give you that tick. Okay, that is why this is crucial, okay? Although it may seem to be, I already got it, you know, write it down. Okay, write it down. Regardless of whether you can draw or not, right? Just write it down. So the second thing that we want to do is to try to create the opportunity to analyze this pair of simultaneous equation graphically. The reason is because the x-coordinates of the intersection between the two graphs is going to be the roots to this equation. You agree, right? Okay, the x-coordinates of the intersection between these two graphs will be the roots of this. And then subsequently, we can move on to the third step to discuss about the roots of the simultaneous equation. Okay? So the second thing, I'm going to try to draw it here. Sadly, I cannot draw. But according to what we have discussed, if I cannot draw the second graph, I will draw whatever I can about the second graph. For example, I know this is a circle with the center at minus 1, 0. Minus 1 is actually here. Okay, the maximum point here has a coordinates of minus 1, minus 2. So vertically up here is going to be minus 1. So the center of the circle is going to be here. But because I don't know what is the radius of the circle, which I'm supposed to be finding out the range of, I cannot actually draw the circle. Okay, I'm going to move on to part 3. So for part 3, we are going to start to analyze the roots of the intersection between this circle and this curve. Okay, and there's a criteria for the roots. The roots must be at least one positive roots. So on the graph, we know that this circle, when it is cutting this graph, right, it must be cutting in such a way that the x-coordinates of the intersection, at least one of them must be a positive number. And my suggestion to you is draw 3 graphs. Okay, if you cannot draw one graph to decide, draw 3 graphs. And the 3 graphs are also dispensed systematically. The 3 graphs will be, the first graph, draw one that is not according to what the question says, or according to what the question says. Depend on what you want. Okay, so if I were to draw a graph that is not according to what the question says, okay, my first graph, then that circle can be maybe something that is like this. Okay, it is a circle that is not in accordance to what the question says, because it is going to give me 2 solutions, and the 2 solutions are both negative x. Okay, and that is not what I want. Okay, so this is a curve that is not what I want, my first graph. The second graph is going to be a graph that I will draw that is in accordance to what the question wants. The question wants this equation to have at least one positive real root. I'm going to draw the circle bigger so that it can give me at least one positive real root. It gives me root, positive root, positive root, positive root. The x-coordinates of the intersections are going to be giving me the root. This is simultaneous equation. We cannot lose sight of that. Once we lose sight of that and then start into just trying to look at the graph, see them intersect, right? Our theory is gone. Okay, so this. Okay, so this is okay. This is my second graph, and this is a graph that satisfies what the question wants. Then I'll draw the third graph. The third graph will be the graph that may satisfy, may not satisfy, but the third graph will be the graph that helps me to answer the question because I've explored. I've explored that this is too small. I explored that this is too small. I've explored that this big one is okay. So by doing this analysis, right, I know the perfect graph for me to make the decision should be a circle that passes through this point. This is going to be a circle that is still not satisfying what the question wants, but I know that as long as it is a circle that is bigger than this, strictly bigger than this circle, it will start to become one that is in accordance to what the question wants, right? And the size of this circle is going to be measured by the radius. We have the coordinates of this point, which is minus 1, 0. This point, we can get it from the y-intercept of the original curve. The y-intercept of the original curve here is 0 minus 2.5. So the last step, I am going to let h be bigger than this distance. This distance is square root of minus 1 minus 0 square plus 0 minus 2.5, so plus 2.5 square. We're going to be getting h to be equal to, we're going to be getting h to be strictly bigger than half square root of 29. But there's a catch in this question. The catch is h that was introduced to you here, right, was never told to you that it is actually representing a radius. It is us who want to see as a radius, which means that h, since we don't know whether it is a radius, can be plus or minus, right? Are we able to decide that it is plus or minus? We are not able to decide. And because we are not able to decide, we will use notation to help us to manage this. The notation will be modulus of h. Okay, it is that detail that we tried to catch just now. If we were to just keep catching that detail about managing modulus, right, after a while, it will become just an instinct. Okay, you will still be considering it, but your consideration becomes part of your habit. And that will become very, very fast. So modulus of h must be bigger than this, which means that h is supposed to be between this square root of 29 and, that means h must be less than minus half square root of 29, or h must be bigger than half square root of 29. Okay, there's these three process. Let's make sure that if we are stuck, right, we at least have something to rely on in order for us to work on such question, okay? Okay, let me continue. Let me take a look at question number 7, a function question. Okay, for this function question, we are given a piecewise function where fx is equal to 4a squared minus x squared, 2a, x minus 2a. This is happening when x is between 0 to 2a. This is happening when x is between 2a to 4a. We are also given fx is equal to fx plus 4a. This is a periodic function also. A periodic function that comes with a period of 4a. And knowing that for part 1, f2019a, you use your own method, okay, to try to break down how many 4a's there are in here. When I did it myself, right, I just tried to divide by 2019 I divide by 4 then see what is the numbers. Then this gives me 504 times of 4a, then plus 3a. Okay, so we know that every time when we minus 4a, it is going to just give me the same output. So I'm going to minus 504 times of 4a. It gives me 3a, which means that this is the same as f3a. 3a is going to be belonging to this section of the domain. So we have this 3a minus 2a. This is going to be 2a squared. Part 2. Part 2, we are going to try to sketch the graph from minus 3a all the way until 5a. Let's do a quick practice. How about let's try to sketch this graph, right, without using the GC at all. Okay, because I really think, okay, being able to sketch graph without the GC is a big advantage. But sketching a graph using the GC, right, has another advantage, which is helping us work on graph that we have never seen before. But those that we have seen before, for example, the graph of y is equal to 4a squared minus x squared. This is just going to be a parabola. Okay, minus x squared is going to be like this. Then plus 4a is going to shift the whole thing in the y direction by 4a units. In fact, here and here is going to be minus 2a. Here is going to be 2a. And we are going to be capturing just 0 to 2a. So if I were to be drawing the graph, y-axis, x-axis from 0 to 2a, the graph is going to be like this. And because I know the exact graph, I didn't just depend on the GC. I know here is going to be a maximum point. It is a stationary point, which means that the tangent is going to be parallel to the x-axis. So I will just, since I have that detail, I might as well make sure that it appears in my solution also. Okay, so we have here as 4a squared. This is 2a. Next, let's draw this. This is going to be a straight line. When x is equal to 2a, it is going to be 0. So you'll start here. When x is equal to 4a, the output is going to be 4a squared. So from here all the way until here. Okay, here will be 4a. And we are going to try to replicate this to the left, to the right. To the right, we are going to go all the way until 5a. 5a. And my graph was supposed to be like this, all the way until 6a. But I'm going to keep just this portion. So from here to here. Okay, so here will be a solid dot since it's going to be less than or equal to 5 endpoints. We must always give the information about the endpoint. So for F5A, this is going to be the same as FA. And FA is going to be equal to 3a squared. Okay, so this point here, maybe I'll just use coordinates. 3a squared, like this. We're going to replicate to the left all the way until negative 3a. So from here, all the way until minus 2a, it will be a straight line down. And then from here all the way until minus 4a, it is going to be a curve back up again, something that is like this. Okay, and we know that when it is at 3a, it is somewhere here, minus 3a. So if we were to work on f minus 3a plus 4a to this, it is going to be fa, which is going to be 3a squared. So at the same horizontal level, maybe somewhere here is where my graph is going to be. And this time, the tangent here is going to be a bit sloped. Okay, not like this. So it's going to be a little bit sloping, and this is going to be minus 3a and 3a squared. Okay, I think you guys are still are really not too bad. Okay, when I take a look at some of your prelims, I can see these kind of details being properly taken care of. But if you also look at J1, right? J1, they are still struggling with big ideas and struggling with ideas they have to create themselves during the exam. So they always miss out small little things. Some of the J1 students, you will see, when they draw this part, right, they'll draw like that. They'll draw it until as if the tangent is going to be parallel to the x-axis. These are not good. These are the places where they will actually lose marks during the A-level. And we cannot be too conscious about this during the A-level, because if I were to be spending too much time looking at these kind of details, right, I also run out of time. That is why looking out for these kind of details, we should try to train ourselves to make it into a habit. 2-3 weeks is already enough for us to develop this. For those of you who are already very into detail all along, right, you'll be the best. If not, you just start to watch out for this. It's going to be very, very useful for A-level. Okay? So part 2 is this. Then part 3, we want to determine if the composite function GF exists. So for GF to exist, we are going to use back the same schematic, okay? So the input will first go into F, then after that into G. So for GF to exist, we want to check that whatever that comes out from F, they must be entirely received by G. So what is the range of F? From the graph, I can see the range of F is going to be from 0 to 4a squared. What is the domain of G? The domain of G is given to me by the question. The domain of G is given to me as 2a all the way until 4a. 0 already cannot go into here. Okay, so it is not a subset. So therefore, the composite function GF does not exist. Okay, so we have this. I actually really like part 4. We are going to try to find in terms of a definition for FG. Okay, we want to find FG. We are talking about putting G into F. Just a very quick practice with your consideration. Okay, you think about it. then consider it. Tell me what you need to do before you can actually put G into F. Before you can actually put the expression of G into F. Can you just think about it? If you can share with me what you think you should do before. Okay, because usually composite function is immediately put the expression of G into F, correct? Okay, but before you put G, expression of G into F, what must you consider? What must you consider? You see, you're going to put G into F, right? You're going to put the expression of G into F, okay? G is fine, but F is a bit strange. F is a bit different because F happened to be a piecewise function. So when you put G into F, do you have a doubt? Pretty, do you have doubt? You have doubt, right? Yeah, that is how we talk. That is what we talk about just now when we were trying to manage the modulus function. A lot of people, when you have doubt, for example, the modulus function, you just assume or you just move on. These are areas where you can actually shine. That's the thing. Starting from modulus function all the way until this, right? Okay. Now you have a doubt, correct? This kind of doubt is very healthy. So how can you? What are the possibility when you put G into F? Now with your consideration now, what are the possibilities? That means G can either be put into the first piece, or G can be put into the second piece, or maybe G can be put into both pieces, right? These are the three possible cases. How can I decide which case I'm going to do? Yes, Jonathan, you're correct. Okay, it is the domain. It is the domain of F that we want to test out. We want to see which piece are we going to be putting G into. This is the additional test. The question didn't tell you so, because this question can be very easily broken up into two parts, but they merge it together. So your consideration will be you first looking for the output of G, the range of G. You get the logic? Okay, we want to look at the output of G, the range of G, and we want to analyze whether the range of G, right, is here, or spanning both pieces, spanning both set of domain. Okay, range of G. You can definitely draw the graph of G by pressing into the calculator, but it's just something that I don't know, I acquired by practicing. Okay, so I'm going to just very quickly show you. So if you are also already starting to see this, right, maybe you can do the same thing as me, because whenever I see something that is like G, okay, it's not always going to happen, but I will think of, in my head, right, I will think of this. This is going to be 4a squared minus x minus 2a squared. Okay, in my head, I will think of this, because if I were to just simply square this, then we will have this minus 2a squared. And if I were to just manipulate this a bit, then we actually have this. So I know that G is going to be a portion of a circle with the center at 2a, y is equal to 0, so it's going to be on the x-axis. The radius is going to be 2a, so the graph is going to be like this. These are the things that if I can see it faster, right, it is going to be our advantage. I already know the curve. Some people still try to take out the calculator and on it. So that's how fast we can be, right, if we were to be looking at a standard graph. Okay, and for G, which is just this portion, because if it is from here, right, going backwards, there will be a plus or minus. Okay, but it is going to be a positive square root, so I know it's going to be the top portion. And because G is going to be from 2a to 4a, we know that it is going to be here all the way until here. So this is the graph of y is equal to gx. This makes it fast, not just fast, this makes it fast and very accurate in exam. Why is there this accuracy? Because we plan for it before the exam. That is why we have the accuracy. If you find out during the exam, you cannot achieve such accuracy with confidence. So from here, we can see that the range of G is going to be from 0 all the way until 2a. Here, okay, it is actually from 0 to 2a. Okay, these numbers are going to be coming out from G, and that is why FGX is going to be us putting G into the first one. So it will be 4a squared minus x squared. Okay? You get it right, pretty. In the exam, you may not instantly be aware that this has happened. But the thing is, in an exam, right, when you try to put G into F, you will realize that this happens. And when you realize this happened, because you don't know which one to put in, then you consider. It is not a flaw. It is a trigger for you to think about it some more first before you act. Okay, it is common. Okay, so when you have this kind of situation in exam, right, don't feel nervous, okay? Because the aim is to at least know that you need to think about it first before you act, rather than you assuming and then you just get it wrong and you're going to spend time getting 0 marks. If you were to consider 1 or 2 seconds, then try to do something about it. Writing it down as my final, this, then x minus 2a square. This is x minus 2a, the whole thing square. It will get you the answer pretty fast. Because when it is a question that requires you to think a bit more, what I realized that your school and the A-level will be doing, okay, actually A-level is more consistent. Your school is not that consistent, but if you were to need to think a bit more, like for example, a question that is like this, something that you will most likely experience during the exam is the working is usually quite easy, quite monotonous, you know, like no special thing in the working. So I spend some time thinking. My working is just like that. In fact, I make it into something that is very, very simple. So they are trying to be fair lah. They cannot make you think like, because when you think they cannot mark, but it doesn't mean that there's no value. So what they will do is, okay, if you think, we will plan so that you just need to write a little bit. We can understand you have already thought about this. Then we can start to give you some marks already. So usually it's going to be turning out like this. Okay, so we have GF to be equal to this. The last part is very simple. The last part, this inverse 27 is equal to 7 over 2a. So to find a, 27 is just bring this over to the other side. Fg of 7 over 2a. So 27 is going to be equal to 7 over 2a minus away 2a, the whole thing squared. Okay, then you solve for a. Okay, last part, super easy. But this is really good. I find this very useful because it creates that kind of opportunity for us to make to do some thinking on the spot during the exam. Let me look at another one. This one I was just thinking whether we should go through it or not, okay? Because it is not exactly that difficult, but I guess it coincides with what I was trying to talk to you about here. When it is a question that is intentionally making students pause and think, they will usually make the solution easy. Okay, so I thought, okay, maybe we should really take a look at this 10A, right? Which can feel quite difficult for some of us to be managing during the exam. But after the exam, right, I don't think a lot of people will even find this difficult because the solution is damn easy. Okay, let's just give this a quick try to have that kind of feeling so that we will not be too scared when we are spending some time thinking during the exam. Okay, but if you are thinking for too long, right? Okay, we are talking about thinking, but think quickly. Don't think slow lah. If you are thinking for too long, then yeah, I think it's better to move on also. So we have this spacecraft that is launched in the year October. So it launched in October 1998. And the average speed of the spacecraft in October 1998 was 44000. And this average speed for that month and all the subsequent months is represented by a notation Vn. So according to that table, V1, which is going to be October 4400, V2, which is going to be in November 44335, and so on. Vn follows the same increment for the rest of his flight. Okay, I mean, we really know it's going to be an AP. Part 1, we are going to try to state the general formula for Vn. This is ridiculously simple. 44000 plus n minus 1 times the common difference. Okay, we can simplify this. Let me do that. Simplifying this will get me 43665 plus 335n. Vn is going to be this. Then part 2. Part 2, in which month and year did the average speed of the spacecraft first exceed 53500? So I am going to let Vn be more than 53500, which is 43665 plus 335n to be bigger than 53500. And this one just linear inequality, so just do your multiplication and division. Okay, I mean don't need to be too much like use table and stuff, you know. So here it's going to be bigger than 29.358. Okay, it is just a simple linear inequalities. And we know that in order for us to answer the question, right, we are going to be looking for the least n. So it is in the V30 when the speed is going to first exceed 53500. But there's something that is interesting about this question, which is they give 3 marks for this. Okay, I think it is a lot. Most schools will probably be giving just 2 marks. Okay, but I can also understand why whoever said this, right, is thinking of giving this as a 3-mark question. Okay, very, very unusual, but I think I know why. It's because, right, this question is damn tough to do in the exam. I'm so scared of this question, okay? But then the problem is there are a lot of students who will keep thinking that, oh, there must be a universal formula to do this kind of question. So they keep asking. They always ask. They always ask teacher, hey teacher, n is equal to 30, I understand. But how do you know which month and which year? They always ask this, you know. There is no, I really don't think that there's a general formula that can immediately from n is equal to 30 tell you which month and which year. You have to do your manual counting. That's the thing. Okay, you have to do your manual counting. It is the same problem for a lot of people. Just in case some of you are thinking, you know, you always have problem with this, right? It is common for everyone, okay? I still remember in the year 2019 or 2020, because everybody stay at home, right? Pandemic, you know, I mean, nobody can really go out. So I also try some new stuff lah. So I try to live stream me doing math on YouTube. It was not fun because it was very stressful for me to be doing that, you know, all the way back then. But then when I was doing this, a question that was like this, right? Wow, it was one of the questions that has spurred the most comments. You know, they will ask, hey, how to do that? How to do that? So we know most people cannot do this, and most people cannot do this, right? Is because they're not willing to put in time and effort to go and manually count it. Let me just show you how I did this. Okay, I mean, don't laugh. Okay, what I did was I look at V1. V1 is giving me V1 is obtained in October 1998. That is what the question says. Okay, V1 is this. So I just basically count all the way until V30. Okay, and when I can maybe use a bit of math to use pattern to just count faster, I will just count faster. If I cannot, I literally just count like that. So then after that, it's going to be November 1998. Then after that, V3 will be December 1998. Then V4 is going to be January 1999. Okay, I think I can apply a bit of math because, right, there's some consistency in this. 4 gives me 1, 5 gives me 2. So if I were to go all the way until V12, 12 minus 3, so 5 minus 3, 4 minus 3. So this will give me September 1999. I mean, and there are some people who just October, they know V12 is going to be September. Good. If you can see this, good for you, okay? But I mean, I didn't see this, okay? So then after that, it will be V13. V13 will start everything all over again, which is 1999. And if I was to start everything all over again, right, it will be another 12. So I'll go all the way until V24. V24 should be September 1 year later, 2000. So if V24 is this, V25 is going to be equal to October 2000. Then we are nearing 30, so I might as well just write V27, 28, 29, 30. So this will be November 2000, December 2000. Okay. Then 1, 200, 1, 2, 200, 1, 3, 2001. So my answer is March 2001. I really literally manually do the counting. Even if it is 1000, you can also count a bit, then jump, then, you know, You just do whatever that you can, in order for you to count all the way until V30. To do this is a very important skill set. In the last few weeks, once in a while, we actually managed to see ourselves doing APGP questions that are related to what we are trying to do here. Like exactly this, is to do the interfacing. Interfacing between math, this is math, V1, V2, V3, right, are notations that is designed in such a way that I can actually implement it into my mathematical calculation. But then October 1998, November 1998, it is a real-life description that is not convenient for me to just plunge directly into math. So there's always that interface, this. I mean, if you start with V1 as January, it will be way easier for us. But they purposely start with October. So we need to interface this, and we also need to try to take into account of the fact that 1 year, there's going to be 12 months, but numbers-wise, I guess we are more prone to counting 10, 10, 10. Okay, so by interfacing these two, there will definitely be some glitches when you go from one medium to another medium. Like in the university, when we learn about aerodynamics, right? We know why planes that are meant for supersonic, to cross the sound barrier is designed differently from the planes that we sit in, to fly, to fly, right? Where they don't need to go supersonic, because it's not because of the speed. Normal plane actually can also go supersonic speed, but it is because of the interface. When you go from subsonic to supersonic, that when you cross this barrier, right, the whole plane will actually rattle super a lot, So you need to make it structurally possible to go to overcome that rattling. Then you go into the other phase. So it will happen, and we want to make sure that we are able to sustain it by just knowing that we have to do things that is like this. Then one more part that is, I think the description is, when I read this, right, I was like, wow, especially when I was trying to do this last part, I was a little bit tired, Then when I read this, I was like, wow, goodness, so much information. But actually, it turns out to be very, very easy. We are trying to look at this. Sum from R is equal to 1 to n of VRT. This is representing the total distance that is traveled by the spacecraft, where T that is here means it is going to be the time taken by the aircraft to be traveling in 1 month. And according to the question, every month there's a fixed number of days. So the hours in 1 month will be 24 hours times 30. This is 720. So T is a constant. Then we are supposed to be calculating for the total distance that the spacecraft travel for 3 years. 3 years is going to be 3 multiplied by 24. We are going, 3 multiplied by 12, we are going to be having 36. So for this question, the total distance is going to be equal to sum from R is equal to 1 to 36 of VR of 720, which is 720. Then we have a V1 plus V2 plus all the way until V36. So it will be 720, and since V is an AP, then we will just do a 36 over 2 of 2 times of A plus 36 minus 1 of 335, the common difference. Okay, it turns out to be really easy. You just need to spend time to understand the information that is given to you. That's why I was telling you that it is fair. Okay, when they need you to spend time to do things that they cannot grade you, they will usually try to make the written part simple enough. So and even more well-designed question, right, will make that written part showcase your thinking.